Good morning. Set builder form. This is the third method to notate a set. To denote a set, we have mainly three methods. The first method is list form. Write the elements in the form of list, like set 1, 2, 3, 4, 5, etc. Write the elements one by one, separated by commas and enclosed in curly bracket. This form is known as list form, and mainly we use this form for all the types. Okay, and the second method to describe a set is using Venn diagram. We use Venn diagram to represent a set. That is second method. And the third method to describe a set is set builder form. Set builder form. Okay. And in this method, it is a way of describing the elements of a set using the properties. In set builder form, we use the properties of the set. We know every set has objects or elements which satisfy certain properties or a property. Okay, for example, set 1, 2, 3, 4, 5, 6, etc. This set has a property. The property is nothing but this set of natural numbers. Set of natural numbers. If we make a set A, E, I, O, U. This set has another property, nothing but set of vowels. Set 2, 4, 6, etc. 100. Set of even numbers up to 100. So all these sets have their own properties. So based on the properties, we build a method to describe a set, which is known as set builder form. It is an easy way to describe a set. Okay, let's see how to frame set builder form. For example, A is set 1, 2, 3, 4, etc. So this is list form. In case of set builder form, what we do is we assume an element among this. Just we assume an element. Let's consider that element as x. You know, x is a variable which can take any values. So here we are assuming a variable, an element from this, which is x. Means x can be 1 or 2 or 3 or 4, any element. So x represents any of these elements. Got it? So we take an element from this and we make x. Means x is a representative. It represents the whole elements. Instead of writing, so what we are doing here is, instead of writing all the elements, we are taking a representative. Like a leader in the classroom. That leader represents everyone. Okay. So here x is an element which represents all this. So we take an element x such that, this dot we use for such that. We have taken an element x. Now we have to describe about x. What is x? That clear information we have to give. Yes, we took an element x. It doesn't mean that our answer is over. We have to give a description about x. That is why x such that x is a natural number. That's it. So we have taken an element from this set, that is x. Now x such that, what is x? That is meant to be this one. X such that, as these are natural numbers, we can write x is a natural number. So how do you make this one? How do you read it? A is set of all x such that x is a natural number. A is set of all x, all the x values, that is meant by all x, all the values of x such that x is a natural number. If you consider another example, C is equal to set A, E, I, O, U. Okay, so here before going for this one, we have to decide the property. What is the property here? A, E, I, O, U, they are vowels. Okay, so here what we do is we take an element x. So what x represents? X represents either A or E or I or O or U. X represents any of these elements such that, so what is x? X is a vowel. Answer is over. Okay. Even sometimes for this such that, some places we use a dash like this, just a bar, a hard sign. So x, here also the meaning is same, x such that. Either we can use this or this one. Okay. Another question. Let's take this one as D. D is equal to set 2, 3, 4, 5, 6, 7, 8. Okay. How do we convert it into set builder form? So as per our method, we take an element x where x is a representative of these elements. X may be 2 or 3, 4, 5, 6, 7 or 8, any of these elements. So x is a representative, x is one of the elements from this. Okay, so x is a such that x is a, what is x here? 2, 3, 4, 5, 6, 7, 8. Yeah, here we have many options. These are natural numbers, they are whole numbers, they are integers, many options are there. But among those, the basic option is natural number. So x is a natural number. So we'll write x is a natural number. You write x is a whole number, doesn't matter. We get the mark for that. Okay. But if you write x is a natural number, this answer is not complete. Why it is not complete? Because if you consider natural numbers are from 1 to infinity. 1, 2, 3, 4, 5, etc. up to infinity. But these natural numbers are from where to where? 2 to 8. Okay, that also we have to mention. That means x is from 2 to 8. X is a natural number and x has a range from 2 to 8. That also we have to mention. Okay. Another question, set x is defined as set 1, 2, 3, 4, 6, 9, 12, 18, 36. Okay. Now, what's the common property you find from this? They are natural numbers but not in order, so we cannot say they are natural numbers. Then what property you can find from this? Yes, it's nothing but they are the factors of 36. What are they? They are the factors of 36. What is a factor of 36? 2, 3, 4, 6, 9, 12, 18. They are all factors of 36. Isn't it? So that's a property. So we can write x is set x such that x is a factor of 36. X is a factor of 36. Got what is meant by that? Okay, and here we don't have any limitation. We cannot give any more condition like previous question because only these are the factors. Okay, let's see another question. This is a question which dealt with a set builder form. We have to convert it into a list form. So set builder form is A is equal to set x such that x is an integer and x is in between 40 and 50. 40 less than x less than 50. X is an integer and 40 less than x less than 50. So we need to convert it into list form. It's very simple. List form means write the elements separated by commas enclosed with curly bracket. Okay. So when you consider x here, x is an integer. Okay, and x is between 40 and 50. So between 40 and 50 means the first value will be 41, 42, 43, 44, 45, 46, 47, 48, 49. Yes, that is the answer for that. Another question is, describe the set in words and say why it is not possible to list all the members. So we have to describe the set in words. That means we have to say its corresponding definition and say why it is not possible to list all the members. Why can't we list all the members of the set? That also we have to identify. Okay, so here what the condition given as x cube is negative. X cube is negative. That means cube of a number is negative. You know when the cube of a number is negative? If a number is negative, its cube also will be negative. So if x cube is negative, we can say x is negative. Like minus 27. Minus 27 is nothing but minus 3 cubed. So here x is minus 3. So x cube is negative means x is also negative. So because if you cube a negative number, if you cubed a negative number, the result also will be negative. Okay, and we know how many negative numbers are there. So what do you mean by this one is, in words we can say that the cube of a negative number is negative. That is meant by this one. Okay, as x cube is negative, x is also negative. You can say like that also, as x cube is negative, x is also negative. Now you think how many negative numbers we can find out. So here what they meant is x cube is negative. That means x is also negative. So that is the thing we can describe in words. As x cube is negative, x is a negative number. So that means A is a set of negative numbers. A is nothing but A is a set of negative numbers. That means A is like set of minus 1, minus 2, minus 3, minus 4, etc. This is not cubed. We are discussing, these all numbers are describing about x. Remember, we are taking x from outside, but x cube is a negative number. This is the rule what they have given. We know that as x cube is negative, x is also a negative number. Okay, so we can say it is a list of negative numbers. It is a list of negative numbers. Okay, and there is no end for that. Okay, so that is why it is not possible to list all the numbers. We can list a few numbers. We cannot list all the numbers of this set. Why? Because a set of negative numbers go to infinity. So we cannot list all the possible elements as it goes infinity, as it has infinite uncountable number of elements. Got how you have tried the answer? Okay. If A is equal to set of x such that x is a multiple of 3, B is equal to set x such that x is a multiple of 5, express A intersection B in set builder form. Okay, so for this question, let us find A intersection B. For that, let's make the list form of both the sets. So A, when you convert it into list form, it is 3, 6, 9, 12, 15, 18, 21, etc. And the list form of B is set 5, 10, 15, 20, 25, 30, etc. Isn't it? When you find A intersection B, A intersection B consists of all the common elements. What is A intersection B? It consists of all the common elements. Don't forget that. So, if you find the common elements, 15 is a common element. Can you say what will be the next common element? Yes, 30. Because there will be 30 here. 3 times 30. What will be the next common element? Yes, 45. And next common element will be 60, etc. It goes on. Okay, and you check this one. What these elements represents? 15 ones, 15, 15 twos, 30, 15 threes, 45, 15 fours, 60, etc. These all are multiples of 15 now. Yes. So what is the common condition? Multiples of 15. Therefore, A intersection B can be expressed as set X such that X is a multiple of 15. Understood? Okay.